Hi everyone, today I'm going through this repeated substring problem. So given a string S, check if it can construct it by taking the substring of it and appending multiple copies of a substring together. So the first example, ABAB is true because this string can be constructed by AB by appending twice, appending once, and you can get it. So ABA is not satisfied, does not satisfy this condition. And ABC, 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 ABC. So yeah, it's a substring of ABC 4 times. And so for the first part, for the understanding part, so the input is clear string and output would be a Boolean value, or whether it's a substring or not, or the substring and then but has this substring pattern. So for the matching part, I think it is similar to some to I don't know, substring, basically just substring problem, or just repeated several times, so maybe it's kind of deal with the modulus operator. So the plan would be so I'm going to take the substring S and then I'm going to append the substring and the third segment to compare the appended string with the input S. And then I'm going through a for loop to start with substring from 0 to 1 up to 3 from 0 to length of S divided by 2 plus 1. So I'm going to check first half of the string and then I will take the substring of it and then append the string to compare with the original input. So what I will do is, so let's define this. So I'm going to start a for loop and then take the substring of it. So y in range from what? From from 1 to length of s divided by 2 plus 1, no, plus 2. And before that, I need to check if so length is from 1 to is greater than 1. So if the length is 1, is that a is there a is that sub does that substring satisfy the substring pattern? Mm, I don't think so. So if length of s is less than or equal to 1, I'm going to return false. So substring sub is equal to s from 0 to I. So I take the substring, and append the substring to, so I need to check how many times I need to repair. So n is equal to length of s divided by length of sub. I'm going to append. So appended string is equal to sub times n. So if appended is equal to s, original s, I'm going to return true. Else I'm going to return. Else I'm going to keep on the for loop. After I checking all of them, I'm going to return false. So let's see whether this will work. Or we can make an example of it. So define main s is equal to ab. So print repeated string pattern s if I'm going to run this. Um, So it's true. So what if ABA is false? So it looks good. If then true, return false. That's fine. Run. It works. So AB output. So let's see. So if length is 2, 2 divided by 2 is 1. So 1 plus 2 is 1 plus is 2. Oh, somehow it's not. So from 0 to 2, but there's no 2. Two divided by 2 is 1. I think there's something wrong here. I actually don't need plus 1. What is 3 divided by 2 is 1. So it works. And it seems like, so I started from 1 to length divided by 2 plus 1. Yeah, I don't need to go over. So I just need to plus 1. So the top of the I is the maximum of I is length of S divided by 2 and put it here. And I will never touch that value when I take the substring. So for example, if the length is 4, so I will take the substring from 0, comma 2. So that's fine. If the length is 5, so 5 divided by 2 plus 1 is 3. Well, notice 3, so the maximum of I is 2. I still take the substring from 0 to 2, 0, comma 2. Column 2. So yeah, that's fine. Yeah. So this is the solution, and when you look at the complexity, So for the for loop, it repeated n over 2 times. So this is O of n times complexity. And then the space complexity is O of n because I use this substring and penny string to store and compare. So the overall the complexity overall is O of n times complexity and O of n space complexity. That's it.